Hi, welcome to another mini lecture. Today's topic is reference angles in radians problem type 2. Let me quickly review what we did last time and then we continue. So topic today essentially about either large angles or negative angles and we want to do these type of problem. Let me show you just one. For example, angle 43 pi over 15 is given and the question is what is the reference angle. All the angles in this section are in radians, and to make the problem straightforward, all of them is on multiple of a pi. Okay, so we said if you have an angle in standard position, so here I have my coordinate system and then I have an angle. So angle theta, I have an angle theta given to me. Now theta can be in the first quadrant, that is, this is our theta, and then we are all done. So theta, if it is between 0 and pi over 2, the reference angle of it is just the angle itself. If the angle is in second quadrant, if you're here, then your reference angle is this one, which is what? So if theta is between pi over 2 and pi, in short, if it's in quadrant 2, so it's quadrant 1 here, your quadrant 2 here, so it's quadrant 1, this is in quadrant 2. What is left? Well, pi minus theta is what is left. So this is the reference angle. Well, what if we are in the third quadrant? In the third quadrant, this is our reference angle. So if my theta is more than pi, but we haven't reached 3 pi over 2, so I'm in quadrant 3, what is that angle? What is extra angle? So take, so if we are going all the way here, well, I have to remove pi from that. So I take theta and subtract pi from it, and that gives me my reference angle. Well, what if I am in quadrant 4, so 3 pi over 2 and less than 2 pi. So I'm now in quadrant 4. I have come all the way here. So what if I go way around and come here? What's my reference angle? Reference angle is this one. This is the reference angle. So how do I find that? Well, it's going to be what is left to get to 2 pi. So that's a reference angle. Okay, so that's what we talked about last time, at least in practice, that's what you did. If your angle now happens to be more than 2 pi, well, then subtract 2 pi from it until it falls in this category. So if, this is all good, as you see, if your angle is between 0 and 2 pi. What if my angle is more than 2 pi? Well, then subtract 2 pi from it. And if it's still too large, still subtract another 2 pi until it is in the range we have here, between 0 and 2 pi. Well, what if my theta is negative? You can use negative numbers if you have a bit of a hard time with it. Here's a resolution. Make an angle that is in the first circle by adding 2 pi to it. Okay, so now let's go ahead and practice. So here are two recipes. If my angle is large, subtract 2 pi. If angle is negative, add 2 pi. So let's go here. 43 pi. So my angle is 43 pi over 15. So is this more than 2 pi or not? So I say 43 pi 15 How do you compare this thing versus 2 pi? Looks like it's more than 2 pi, is that right? How do you easily check? Well, multiply by 15, you see 43 pi is larger than 30 pi. So of course it is bigger. So what do we do? So it's 43 pi 15, subtract 2 pi from it. So I have to take the common denominator, 15. This is 43 pi. 15 times 2 pi is 30 pi. I subtract it, I get 13 pi over 15. So this is obviously less than pi, is that right? Because the 13 over 15 is less than 1, is an angle less than pi. So if it's an angle less than pi, means, well, I haven't crossed this line. So it's either number 1 or number 2. We can quickly guess where it is because it's kind of close to pi, is that right? So to make sure, if you are not convinced that this is in quadrant 2, so I claim this is in quadrant 2. How do I know that? I say it's more than angles in quadrant 1. It's more than pi over 2. Is that right? Well, how do I know that? Multiply by least common denominator. You're checking any inequality. Is this true? Multiply by 30. So this becomes 26 pi and this becomes 15 pi. What did I do? I multiply by 30. Where does 30 come from? 15 times 2. I multiply by 30 so that denominators clear out, and I know that this is larger than that. It means this angle is more than pi over 2, which means I am in quadrant 2. Okay, in quadrant 2, what do we do? Take your angle and subtract pi from it. So I say pi minus 13 pi over 15. So I take a common denominator, 15. 15 pi minus 13 pi, and that is 2 pi 15, and that is my angle. So what did we do short? This is a large angle. I'll subtract 2 pi from it until it comes to the first circle. So when I subtract, I get 13 pi over 15. This is a slightly short of a pi, see, because 13 over 15 is close to 1. To be sure, I am checking to see I'm really in quadrant 2. I compared against angle of pi over 2. I want to know, okay, so this is pi over 2. I want to claim that 13 pi over 15 is in quadrant 2. Well, I compare against pi over 2. Well, how do I compare? Multiply both sides by the lowest common denominator, which is 15 times 2. Multiply by 30. When I multiply by 30, this becomes 26 pi, and this becomes 15 pi. Obviously, this is bigger than that, so I'm assured that I'm in quadrant 2. Once I'm in quadrant 2, question, well, what is left to make it to the horizontal? We say pi minus your angle is what is left. Okay, so let's try one more time. Here I have another angle. This time this is negative. So again, you have two choices. Straight out deal with negative numbers. If you're comfortable, that's perfectly right. If you want to use the recipe we have up there, so this is, here my angle is minus 7 pi third. It is negative. So let me add 2 pi to it. That is going to be giving me a co-terminal angle. So I'm still in the same location as before, just that I am making my angles a little bit more comfortable. This is 6 pi, and this is minus 7 pi. So I got minus pi 3. I'm still negative. So I keep adding. So this one minus pi over 3. So now I have 3. This is 6 pi minus pi. This is 5 pi third. Okay, so we kept adding 2 pi's to this until our angle is positive and in the first circle. So maybe you can see right off that here, this is more than 2 pi, so I needed to add twice to it. Now the question is, where is 5 pi third? 5 pi third, you notice that's close to 2 pi, is that right? So we are close to making it back. If I was to guess, 5 pi third is making it all the way here. Well, how can I be sure that that is where I am at? I say, well, this is 3 pi over 2, is that right? To make sure that we have passed it and we are in quadrant 4, all I need to do is to show that this is more than 3 pi over 2. So 5 pi third, I want to verify, I'm checking, is this more than 3 pi over 2 or not? If my guess is correct, then well, then what do we do? If I am in the fourth quadrant, my reference angle is 2 pi minus the angle that we have. So how do we verify? Multiply by 6. Where do I get 6 from? Well, multiply by the lowest common denominator. So, or cross multiply, however you want to do it. So this becomes, excuse me, 10 pi, and this becomes 9 pi. Is that right? When I multiply, this is 10, and that is 9. And this is correct. So I am actually in uh, quadrant 4. And what was our recipe in quadrant 4? We are trying to figure out what is this angle, huh? What is that? And so if this is my theta, what's my reference angle? It's going to be 2 pi minus theta. So I said 2 pi minus 5 pi third. Take a common denominator, 6 pi minus 5 pi, and that gives you pi third. And so the answer here is we are at pi third. So just as a matter of check, you always check to see that whatever angle you get at the very end has to be between 0 and pi over 2. It has to be positive and less than pi over 2. So then that would be one primary check for you. Let's go do another example of this. This one says minus 34 pi over 15. Again, a negative angle. You're welcome to deal with the negative angle straight out, or just as the recipe we gave, add 2 pi's to it, find a coterminal angle that is positive, and then apply the recipe we had before. So if I want to add 2 pi's to it, can we guess how many 2 pi's do I need to add to this? You notice that 34 is more than twice this thing. So if I add 2 pi to this, I'm still in the negative territory. So I have to do it twice. So I learned from my last lesson that well, let's go step by step so that everybody clear about this. I added 2 pi to this. I take a denominator 15 minus 34 pi, multiply this by 50, because 30 pi. You add to it, you see, I'm still dealing with a negative angle. So that's why I said this is more than 2, this fraction is more than 2, so I need to add twice. So I have minus 4 pi over 15. I need to add another 2 pi to it, and I repeat. So this becomes minus 4 pi and another 30 pi, and now I have 26 pi over 15. So where is our final angle? Just like the last problem, 26. This is almost close to 2 pi. So I have, it looks like I've gone all the way. I came to quadrant 4. Let's check. Is this true? Our guess, is it correct that if I have 26 pi over 15, does it end up in quadrant 4? Well, let's check 26 pi over 15. We compare. We are thinking that is more than 3 pi over 2. Well, how do you check? Cross multiply, multiply by this by 2 becomes 52 pi. Multiply that by 15, and that's 45 pi. So I cross multiply this one times that, and this one times that. So this is true, which means I have crossed that boundary. I am indeed in this quadrant 4. Question was, are we in quadrant 4 or not? Yes, we are in quadrant 4. And then what's our recipe? Our recipe is to take 2 pi and from that subtract the angle that you are dealing with, the last angle here, which is 26 pi over 15. Take a common denominator, 15. This becomes 30 pi, and this becomes, well, it was 26 pi. Subtract 4 pi 15, and that is the final answer. Again, double check that this is a positive, obviously positive. Is it less than pi over 2? Okay, this has to be between 0 and pi over 2. That is a half check on our answer. Is it correct? Yes. Okay, let's see. We have one more example. Minus 13 pi over 5. What do you think? How many 2 pi's do I need to add to this? Again, this needs to add, we need to go through 2 rounds of it. So I just do it in one stroke. 113 pi, and this is 20 pi. So I have 7 pi over 5. So the question is, where is 7 pi over 5? 7 pi over 5. Do you think we have made it in to quadrant 4 again? Let's see. 7 pi over 5 obviously is more than pi, so maybe we come here, or perhaps maybe we have come over there. So let's see, is this still more than 3 pi over 2 or not? So let's cross multiply. This becomes 14 pi, and this becomes 15 pi. So no, it is not crossing because this is bigger. So I'm stopping in quadrant 3. I'm stopping quadrant 3, and then how do I find my reference angle? Well, subtract pi from it, so 7 pi over 5. Subtract pi from it, so 5. 7 pi minus 5 pi, 2 pi over 5. And this is an angle between 0 and pi over 2, so chances are we are all on the right track. What if we hadn't realized, what if we had made a mistake here and we thought we are in quadrant 4? Well, in that case, when you calculate your angle here, you are gonna get something that is more than pi over 2. Like if you had said 2 pi minus this, you would have gotten 3 pi over 5, and that's more than pi over 2. Okay, so the discussion became a little bit refined here. We're dealing with inequalities with the pi thrown in all over the place. Before I close today, let me add an additional challenge problem to those of you who might want to do some additional thing to get ready for calculus and flex your muscles. Suppose I have an angle. Let me remove that kid glove and remove it with the pi. So suppose I have an angle that is 10,000 radians. What is the reference angle? So why is that a bit challenging? Because the angle is large, and you have to find a systematic way of handling it as opposed to the method that we talked about. So we are going to leave it on the side for those of you who are interested. There's no question on Alex like this. There is no, this is not a homework or anything. Just if you're interested, you let me know. Okay, so what happened? Quick review of last time. If an angle is given and it's between 0 and to 2 pi, well, it's in one of these three quadrants, either here or is here. How do you write it formally? Between 0 and pi over 2, or pi over 2 and pi, or pi and 3 pi over 2, and 3 pi over 2 and 2 pi. That's how you decide which quadrant you're in. If you're in the first quadrant, then the angle that you have is fine. If you're in second quadrant, the reference angle is pi minus what you started with. If you're in the third quadrant, theta minus pi is the reference angle. If you are in quadrant 4, your reference angle is 2 pi minus angle you started with. Now, if the angle is more than 2 pi, keep subtracting 2 pi's from it until it is in this range. If the angle is negative, keep adding 2 pi's to it until the angle is in this range, and then apply the ideas we had in this table. Okay, I hope it's clear. Do as many exercises as it takes here until you are all comfortable. Until next time, good luck and God bless.